Welcome to part 1 of the RCA 5T radio. What I did last night off camera is cut out electrically those two wet electrolytic caps and replaced them with two 10 microfarad 450 volt electrolytics. That's what it calls for, 10 microfarads in each one. There's only two filters in this. The radio plays. I replaced a couple of paper caps in there, but that's all I did so far. Let me turn it on. We'll see how she goes. Okay, we're plugged into the Variac. We got the Variac up to 49 volts now. We got about a 3-foot piece of wire on here. Now, last night, when I tried this out, I put my finger on the antenna terminal. I didn't have a wire on it on the back. And I happened to have it on this shortwave band, and I was picking up the guys I usually listen to on 80 meters. He came in very good. Either it was the conditions were good, or this radio was very sensitive on the ham bands. One or the other. But anyways, we're going to crank up. We got the volume. I don't remember which is, there's not marked here, volume or anything. If they are, they're going. I don't know which is which. One is the band switch, one is the on and off switch. One is the tone, but when I turn it all the way to the left, the radio goes out. So I'm not sure if that's an on and off switch also. I have to trace it out. The problem with this schematic is there's no voltage readings on it. I can't find any voltage readings. So I don't know what the voltage is in those screw and pilot lights. I really don't know what they are unless I put a meter across them. One of the sockets fell apart, and I'll show you that. When I went to put it back into the cabinet to try it out after replacing the electrolytics, I cut out the electrolytics that were in here electrically, put in the terminal strip, and put in 10 microfarad at 450 volts. So there's two of them in here. So let's crank this up. We're drawing 200 mils right now. 300 mils at 85 volts. $400 mils at 93 volts. $500 mils at 100 volts. I would say this is probably 115, so we're going to put it up to 115. Well, 115, we're still doing 500 mils, and the analog meter is showing about 500 mils also. Okay, now, I didn't change the band on this. This is the shortwave band right now. Now this is the volume. Picking up little interference in the shop here. Volume's all the way up. I wouldn't expect anything on the shortwave. Let's see. I think this is the band switch. It's very noisy. I haven't done anything with it.
And 98.9 FM, WHYN Springfield, an iHeart radio station.
Good morning, 8 o'clock. It is 79 degrees in Springfield, 78 in Worcester. I'm John Babine. Here's what's happening. Tornadoes across western Massachusetts. Sandusville, Holland is
volume's all the way up.
There have been no injuries reported, but some damage.
I have not replaced the coupling capacitor in the audio output tube. Those things are going to be done.
Looks like everyone has their power right now.
We don't want to run it too long in case.
Governor Roy Cooper
What I did replace, the ones I did replace are very, very leaky.
Cooper says it's a good idea to pack masks and
That was the low end of the broadcast band.
At night in that house with everything open, blowing through. I mean, it would get, you're right on the ocean like that. I mean, it gets to like, 72 degrees at night. There were some nights it was actually cold in there.
Oh,
They were
okay.
finding, I almost set a fire in the stove because it was actually cold. So I didn't need it. I just left it.
I think this is the tone control. I don't know if I'm in camera or not. The camera's off to the side as always, and I can't see the viewfinder.
Somebody else deal with it. Just have it, sell it somewhere.
Yeah, that's the tone. All it is just a bypass capacitor to cut the highs.
Just like here. Just that thing. I'm not looking this thing back. But yeah, it's right.
You see, it shuts it off when you go
That's like
extreme left.
That would be phenomenal if it worked out.
Again, but if you refinance, you take a little money out of your house, you might have
All
enough
right.
money to buy one.
But
Yeah,
if I turn the band switch over, it shuts it off too.
I don't know your
refinance
financial
for it to
system.
work.
I don't
See? Well, actually, it don't shut it off. I think what it does is it goes to phono.
that way, that's all.
How many summers?
No,
That's true. How many months? Water.
no, it doesn't either. No, that's two bands.
Second. Well,
That's two bands. Okay. The problem is this is not marked. There's no markings on these at all. It don't look like there ever was any marking on these. This is the volume. You can hear a little bit of static. So there's no hum in this at all. All you're doing is picking up noises from the line and the fluorescent lights and stuff like that. So this band switch has got to be cleaned.
back
They're
there.
only back about 70.
Yeah. Well.
President Trump's support.
Is why you should try ZipRecruiter.
And into the city, you can do that in just under a half.
U.S. Interior federal judge's ruling that blocked it from rescinding a reservation designation for land belonging to the Nasty Wampanoag tribe in Massachusetts.
We're getting a lot of interference here. Shut my light off here.
Otro hijo más. Y luego de este aún se atreve.
Offering a variety of amenities for long-term care and uniquely qualified team specialists.
Well, I've only got, don't forget, I've only got about a 3-foot piece of wire, a clip lead connected to another clip lead. It's very hard. The dial light doesn't light, of course, because I got to replace the bulb and the socket. My screw-in socket fell apart on me when I went to put this in the cabinet. I had to put this in the cabinet because I couldn't run it on the bench because the speaker has to be plugged in. The cord is very short, so the chassis had to go back in. So I'm not able to run voltage checks and stuff unless I pull the speaker. And if I pull the speaker, I could run the risk of knocking a hole in it.
Saved $19,000 in the washing machine. Also, he's cleaning, he's laundering his money.
All right, let me get this light back on here again. You can see the socket fell apart. And not only did the socket fall apart, but this here little light shield, which had the hole in it that I showed you, just fell right off. And it's like this one here, but all it is cardboard. And I guess another piece could be stuck in there, but I wouldn't use cardboard. I don't know what to put in there. I guess it protects the plastic so that bulb heat doesn't burn it out. But I have no idea other than putting a meter on it. The problem is I cannot run the radio on the bench here unless I take the speaker out and set it on a bench, and almost certain I'll knock a hole in it. Years ago, what I used to do on these radios here that had field coils is, I've done this many times, is to replace the field coil with a filter choke. I used to have lots of filter chokes, a lot of them from old televisions and stuff. And I used to put the filter choke where the field would go, and then just run your voice coil to a regular permanent magnet speaker. And that's how I'd run them on the bench if I didn't want to take the speaker out of the cabinet. Well, anyways, this is an 80, this is a 42, and we want to make sure that the coupling capacitor is replaced before we go too far. And I will show you under the chassis. I don't know. Let me pull this bulb and see if I can get a number off of it, and then I could probably look it up and find out what the voltage is. If it's a 6.3 volt bulb, I could probably put in a 47. Well, trying to get the bulb unscrewed, it fell apart even more now. So I'm going to have to replace that with a 47. I got to find out what the voltage is on these bulbs. I'm not going to let this hold me up on the radio. We'll figure something out, I guess. I can't make out any numbers on this bulb at all. And I cleaned the base. Cannot make any numbers out at all. I see something there, but even with my eye lobe, this thing here, cannot see it. So I have no idea what the voltage is on this bulb. Okay, here's the terminal strip I put in. Here's the electrolytic I put in. I replaced the capacitor right here. And I replaced another one down here. Now, according to the schematic, there's a bypass capacitor. On the schematic, it says 0.25. What was in here was a 0.1, original. So, disregard what the schematic says. I go by whatever's in the radio unless somebody had replaced it. This has never been worked on. As far as the components are concerned, only the cord was changed. On this dog bone resistor here, I'm getting, it's showing 22,000 ohms, 27,000 ohms. But the body and dot code don't match. I'm reading 29,000. I had to cut the lead short to the old electrolytic, which is right here, the base of it. That's all is left. So I had to add a little extension to it and connect it to the positive side of the 10 microfarad electrolytic that I put in here. So that's working out good. It don't look too sloppy. I soldered it good, put a little hook in it, because the lead was only not even a 1/4 inch long. I find a lot of these capacitors that are buried underneath soldered down very close to the chassis when they are used as bypasses, where you can't even get your nippers in there to cut it off. There's going to be a couple I'm not going to be able to get at, okay? But I should be able to replace the coupling capacitors. The problem is the bypass capacitors. Those seem to be the ones that are inaccessible for the most part. Not all of them. There are a few in here. So you can see, yes, I'm using a screwdriver as a pointer. Sometimes I can't grab a pointer, so the old fingers were invented before pointers were. So I'm leaving this dog bone in here because it's not matching the color code, body and dot, from what I can see, and it's very hard. The body is red, at least wise. It appears red. end could be here, it could be here, and dot. I can't make that out. So this is very close to 27,000. So on the other schematic, which is not my radio, the 5T1, which is a different model, it shows a 22,000 ohm resistor here. So this is the 5T, not the 5T1. That's this radio. So I'm figuring that this is probably just up in value a little bit, and I decided to leave it in. Now, let me see if I can get you a little better angle and point out some things. Okay, get a flashlight in here too to make it a little easier. Alright. This one here is buried way up in the corner. I can't even get a nipper in there. I can cut this end without a problem. I can't get at that. So, this is rubber wire here, this green wire. This red wire over here, which you can just barely see in camera, is rubber coated. I don't want to disturb it. I would have to literally remove this switch, which by the way has got to be cleaned. I think this is the band switch. Remove this and a lot of this stuff, and by the time I get through with it, it's going to be a total disaster trying to put it back together, so I'm not going to touch that. That capacitor will not be removed. I think a lot of these are bypasses. The biggest worry is coupling capacitors. I'm not too worried about it if they're in the RF circuit, and this apparently, this tube here, I don't know. I'd have to look on the schematic, on the tube location diagram. I don't know offhand what this tube is, but I can look at it easy enough in the schematic. And find out what it is, but I don't think it's going to be anything that's going to cause a problem. I don't know what that far end, which you cannot see beyond this screwdriver point, because I'd have to remove this switch, remove this, remove all the stuff, including maybe even some of what I put in here, and that was not easy doing. I'm not going to do that, okay? And up here I replaced a... don't remember, I think it's a 0.5. The thing is, this capacitor is a 0.5, not a 0.25. Well, naturally, you can't get a 0.25 anymore, you get a 0.27. That's fine, that's okay. So this is a 0.27. This one down here calls for, on the schematic, a 0.25, but it's clearly marked, the one I took out, a 0.1, and I'll show you that capacitor that I pulled out last night. This is what I took out. Alright, 0.100, okay, 200 volt, okay. So that's what came out of there. So I'm not going to, in spite of what the schematic says, I'm not going to go putting in a 0.25, even though the schematic shows it. There's nothing else on that capacitor, okay? And these leads are super short. This was hugged right against the chassis. And this end was the right side of this up here. So I had a job getting this out, but I succeeded in connecting the grounded side of that 0.1 to the ground lug, which is off camera, of course, of the terminal strip here. Okay, so that worked out all right. You can see I removed the stud. This is the one that had all that dry stuff coming out of it. Installed a terminal strip here. This red wire was on here. It is now on here. There's a 10 microfarad capacitor here. And this is the positive and this is the negative. The negative is floating. It is not chassis connected. And it goes right to here. Okay? So there's a wire from here over to here. You can see the little blue wire I put in there. So that connects that to there. So the negative of these electrolytics, this one and the one I just showed you the first time, negatives are floating. They're not chassis ground. So that's part of your bias for your audio output tube. Let me pull the schematic. Fino wanted to have me go over the schematic. We can do that, but there's some discrepancy here. Again, you can see these capacitors here. They're all original. So if the schematic calls for a value different from this, I'm disregarding it. I'm replacing the capacitors as they are the ones that were in the radio. The exception would be if somebody had worked on this, then I would go by the schematic. So you can plainly see these are original. So you don't go by the schematic and replace it. If this is a 0.1, for instance, I can't see that. Sorry. My eyes don't permit me unless I get right up on top of it. But you probably can see it. I think it's a 0.1. They're a little different than what I'm used to seeing. 0.100, reading this upside down. So if the schematic for some reason calls for a 0.25, I'm not putting a 0.25 in here. That's plainly factory. This happens to go to the ground of the ground terminal. So you're not really connecting a ground wire, earth ground wire, on the chassis. You're going through an isolation cap right here. That will be changed. But that calls for a 0.1, so I'm not going to put anything else in it. Everything, as you can plainly see, is original. Okay? Now, there are some caps that are going to be an SOB to get at. That one there is going to be, but I'll do all this off camera. That's for sure. And I'm going to be very, very careful. These leads are down to the terminal. It's the way they made it. So I can't even do my hook and pinch. So the next step is tacks out of it. I do not try to clean the terminal off and clip off the excess. I do not do that. That is how I ruin tube sockets and terminal strips. On one of my radios, I think I did last year, I don't remember which it was, I destroyed a terminal strip such as this one right here by trying to snip off what I thought it was a piece of wire hanging, and I ended up cutting the terminal strip right in half. No, I'm not going to do that. So, anyways, this is another look at this. It's not a neat looking job, but it's functionable. So, I want to find the coupling capacitor to the audio output tube, and the audio output tube is going to be right there. Okay, that's the audio output tube. Now, according to the identification on the schematic, it says 470,000 ohm grid leak resistor, which is quite common, but these two resistors here, these dog bone resistors here, don't have the color code yellow, purple, violet, is it? I have to look on my cheat wheel. Hang on. Thank goodness for these things. I rely on these all the time. Yellow, purple, violet. I mean, yellow. Oh, man. Man, what's the matter with me today? Yellow, purple, yellow. 470,000 ohms. Well, the bottom one is yellow, but it looks like a black dot on the left. So that is not a 470,000. Okay, so I'm estimating this could be the coupling capacitor. Regardless, I'm going to change it anyways. I'm pretty sure that's the coupling capacitor, and as I recall, that's a 0.01. So that's correct. The schematic calls for a 0.01. Now it comes from the 75 tube, which I believe is right here. Turn you around here. I think that's the 75. I'm not sure. As you're looking at the far end, the 80 is down here on the right, and the 42 output tube is right there next to it on the left. So I think this is the 75, the grid cap. So there is no coupling capacitor here. So somehow this capacitor ends up over here. But regardless, I'm just going to shotgun it and change it anyways. As long as I can get at it. The one over here, see where the shield is for the tuning condenser? That's so tight against the terminal. Well, we can try to get it out, I guess. We can chop it up, but I don't like doing that because I'm going by the value that's in here, not by the schematic. Let's go to the schematic because Pino wanted to see that. So on the 5T1, which is not my radio, we're showing a 22,000 ohm and 6,800. But that's not my radio. Okay, on this is the 5T1. Okay, it shows that looks like a 27,000. But it could be 22. Okay. And as you can see here, these two capacitors, this is correct. This was a 0.25, which is what was in the radio. Okay? This is not a 0.25, even though the schematic says it is. What's in the radio, and it was original to the radio, was a 0.1. So that is what I replaced it with. You can't always go by the schematic. I'll look at it with my magnifier here. Upon very close examination, under my micro eye lobe, there's a 0.25, 0.25, 0.25. So I replaced this because what was in the radio was a 0.25. I replaced this. What was in the radio was a 0.1, not a 0.25. So that's the way we're going with this. So this looks to me like a 22,000 or a 27,000. If it's a 27,000, I'm reading about 28, 29,000. So I'm not going to replace it. It don't need to be. And again, we're talking about this resistor right here. This reads 29,000. I mean, in the future, I can change it. It's probably about 2 inches long. I'm guessing about 5 watts. But it's a rough guess. I really don't know. But it's easy enough to get at. I can tack in another resistor here, but I don't have anything that would be that higher wattage. I'm pretty sure this has got to be over 2 watts. I know the old dog bone resistors are larger for the same value of wattage than the newer ones. Okay, so that's where we're at right now. You can see, and I gotta find my flashlight. Okay, so this is very tight. You can see how they did it. They took these caps and I don't know how they did it, but I'll tell you, I don't know how to even get a soldering iron in there when they assemble this. They made the lead so damn short that my hook and pinch method is completely out the window. So if it gets to a point where I can't get at them, I'm not going to worry about it. If I can get at them, all right. If I can cut them off, even if I have to just tack them in, because I'm not going to risk damage to the terminals on any of these. All right. But what I want to concentrate on now is the coupling capacitors. And I'm just giving you a run through of this. Now, this is the on and off switch here. It's kind of unusual the way they ran the wires. I'm going to have to put the light down here. Hopefully you still can see it. That the wires, both the neutral and the hot, go directly to the switch like that. It's kind of an unusual setup. Usually one wire goes to that and the other one would go to the transformer, but it must be a unusual type of switch. But it does work. You probably need a little deoxit in there, and the band switch definitely needs to be cleaned. So what I am going to do with this off camera is I'm going to spray some CRC cleaner and just rinse it off and clean it off, let that dry, and then hit it with deoxit and work that back and forth. And that's what I do with the tuning caps. I brush them with that little round brush I got, get most of the dirt off, try to blow it out if I can, and then hit it with CRC cleaner, let that dry, and then oil up the ball bearings and so forth. So I don't know what this is, some kind of an adjustment here, but you can see the red and the blue wire right here, and the green wires and the red ones over here are all rubber coated, and the yellow one underneath. So that would be an SOB trying to redo that. So I got to be very careful. This cap right here that I'm pointing to with my flashlight here, it doesn't look too bad to get at. You just unhook it. But it's in the radio circuit. It's not any, I'm sure it's no high voltage there, but it should be replaced along with this one here. And I am very doubtful if I'll be able to get that one. Okay, so that's yes. And one of my viewers told me that this is a tune coil. He told me what it was, trap or something, I think it was. All right, so that's fine. All right, so overall I think it's about as good as it gets. So we gotta work on the coupling capacitors, because that's important. You don't want to have a problem with the audio output tube getting damaged for a leak by way of a leaky coupling capacitor. All right, this is the tone control capacitor. It's, according to the schematic, it's a 0.017 microfarad. So 0.015 is the closest, otherwise 0.022. I already looked it up on the computer. This part number does not show up in the parts list. And let There's the capacitor. I'm going to put in a 0.015. I got the leads here so I can hook and pinch. But it would be nice if I can get it in here, but it's not. Doesn't seem to be a waxy. I'm going to try to open this up and probably stick that in so then I can mount this here like this. Okay, where it was originally. If not, we'll just go across here and be done with it. It only shows one tone capacitor in here, yet you've got an off position on the switch, and I cleaned these with all deoxide already. Off, normal, tone 1, tone 2. Well, there is no tone 1. There's only one tone capacitor in this. Okay, I took a chance. I took my lineman's pliers and I hooked it on here and I pulled the guts out of this. So that's pretty neat. And this will be my first capacitor restuffing. The only reason I'm doing this is I want to try to get it into this bracket here, you know. So I'm going to put this 0.015 in here. Probably build it up with tape, and I'm not going to go in with shrink tubing and all that stuff. Now there's an end piece here, which we take off. So we got a little hole in there. So what I'll do is I'll do this off camera. I'll wrap this with electrical tape, shove that in, and put the end cap on there. I could put hot glue in there. I could do that, I guess. But more than likely not. Well, we'll see what happens. Okay, I didn't bother getting a hot glue gun out. I just put some tissue in there and shoved it in there and put some electrical tape on the capacitor to kind of fill up the void. They had these little discs in each end. I can only do one. I could not do the other, so I didn't bother. But this way, this whole thing will fit right in there. Now, this restuffing capacitors is for the birds. I will not do that. But I'm doing it on this because this bracket here, it would look better with a original looking cap in its place. Otherwise, I'd have to eliminate this bracket, which I don't want to do, and it's riveted in anyways, and just put a capacitor in there. So to try to keep it looking a little bit better and more original, we'll do that, and I'll write on here 0.015 new replacement inside, if I can write that small. Okay, this is my so-called restuffing. It worked out pretty well, actually. It calls for 0.017. I didn't have that, so I put in a 0.015. The next step up would be an 0.22. It's the tone capacitor, but there's only one. Why there's two positions, I don't know. But I managed to get it on the terminal. Of course, tack soldering, the only way it'll get it on there. And hook and pinch down here. That worked out good. So this is back in. It's nice. This is the power cord. It looks like the guy just wrapped it around, whoever did this. So we're going to have to redo that. We can probably just solder it up rather than to take it off. These caps were changed. This one, I think it's a 0.01, and this says looks like 0.010. So I am not sure about this. It is jammed in so tight here that I'm not going to deal with it. It's too tight to get at. This one here goes on the volume control. It's wedged up tight. I think it goes on this terminal right here on this coil. I am not messing with that. This end I could probably get at, not a problem. This end I won't be able to successfully even if I could clip it off, I'm not going to be able to get another one in. So we leave that. This is another one we're going to leave in. It's also part of the volume control. So those are relatively low voltage anyway. So this, and this will not be touched. If I'm not sure of the value, you can't put a capacitor meter on these because they're going to read wrong because they're so leaky. This one appears to be a 0.100. So that don't look too bad. I can replace that. This one here is a 0.1 also. So that these two can be changed, not a problem. This I'm not sure. If I can get a reading, if I can see something on it, okay. And this one here. Okay, so what's not going to be changed is this one. It's impossible to get in there without cutting everything out of here. This is similar to, not as bad, of course, as that Gonset radio. So we leave that alone. Leave this alone, this one. And I am not sure about this. I tried to look it up in the schematic. I think it's a 0.01. But I am not 100% sure exactly what circuit it's in because I can't see this end. This could be grounded. This could go to here. It could go to here. Really don't know.